Hello, hello. Hello, hello. Oh, why am I hearing myself? There we go. Oopsie. Okay. So, after the last stream, we've officially fixed all the ambiguity stuff that was popped up. So, today I can finally move on and do the stringification for snippets that I wanted to do. And after that, I think I'm just going to start going through all of these to-dos that we've built up here, which if I go to specifically for just here, there's a lot of them, so there's a lot of to-dos here, but and really, yeah, so this is all just in what will eventually be our platform layer, but a lot of these to-dos are from the metaprogramming, so in the actual metaprogramming, metagen stuff, there's a decent amount here. I'm not sure how many of these we have to go through, but I'm gonna start in just the platform layer stuff and see where we get. So let's do it. Let's start by compiling, just seeing where we left off last time. We are compiling, we are running. So the thing I would like to do is let's make a snippet down here. And actually, I wonder if no, it's fine. Snippet, we'll just say stringify. And we will take a argument. And I want to be able to say short string string is like this, stringify argument, I guess, something like that. And this stringify I guess it'll be specific to snippets because we want to expand whatever this is and stringify that, I guess. So, for example, where are we? Here we go. So, in a macro, for example, you have an expression, you have a message, and somewhere in here, we have this stringify. Right, so here we go. So you pass in an expression here that we can check against as a bool, right? If not expression. But you can also stringify that and get that piece of text literally as a string. So I think we can do that quite easily because we already have like an append node as string. That's how we're spitting it out in the code. I think we can just do that and create a string literal out of that on the tree. So first things first, let's add the stringify as a keyword here in forcoder, so it'll light up, which is in custom languages. Yes. So I just have a thing here, custom keywords, custom preprocs. We're gonna add a new one. This will be stringify and stringify. Okay. So there's that. We can close this and let's software forcoder custom bin. I have a single script that does this whole thing for me. Recompile the custom layer, replace it, all that stuff. Okay. So now I should be able to open up the code base. Go to main. And we should now have, that did not work. Okay, why didn't that work? That's weird. This should not be. Stringify. That's weird. Why didn't that work? This should not be the hard part, so I'm a little confused why. Oh, wait. That didn't crash forcoder. That should have crashed it upon doing that. When it reloads, in the past that has always crashed forcoder. So am I not editing the right thing? Oh, there it goes. Okay, there it goes. Weird. Something weird's happening. Still, is it because it's... No, why is that not working? That's really strange. Again, this should not be the hard part. I can have a comma there, can't I? Is that, I hope that's not it. That would be stupid. Oh, wait, I can do it over here. Oh, I closed it. What am I doing? Okay. Let's try that. Maybe that comma's messing the whole thing up. I don't think it should, but... No. What the hell, man? Okay, let's make sure that this is doing anything at all. Right, let's remove snippet from the custom directives and see if that goes away. Which it did. You can see it did. Why? Is there a chance it's too long? I don't think that's a thing. Snippet depend. No, it's not too long. Bro. Let's open this whole thing and search for stringify. They do use a stringify macro, but that really should not matter here. Oh. They use this already. How about we just don't... how about we do... Okay. They already used that for something else, so we'll call this like C stringify. How about that? That's dumb. Well, it's not dumb. It's just it's interfering with what we're doing over here. Stringification is what it's called in C, so that it makes sense that you're using that. But there we go. Okay, great. So now we have stringify. Let's add to the lexer custom keywords. Simple directives will be, we'll add stringify. It'll just be a preproc, I think. I don't think it needs its own special case. It does take parameters though. So let's go to the parser. Preproc. Starts expression. So stringify does. Right. So now we need to find where we parse preprocs. String concat node, parse literal. Okay. Oh. Okay, hold on. Custom simple. This is not a simple directive, so hold on. Simple directives. See, I would have thought simple directives don't take parameters, but like any of technically does. Let's just go with it. Custom simple directives. So if we see a preproc, we match it, we grab it, we create a marker. Right. Hey, Maddie, how's it going? So these are for markers. This is not really what we want here. I think what needs to happen here is this is not... I think we want our own custom thing here. Well, I don't know how we want to do this. Let's look again at the markers. Got the basics of generic structs laid out. Cool. Hopefully it wasn't too complicated. I know when I did my generic struct template stuff, it was a bit of a wild ride, but we got there. Okay, so this is a marker. This is not a marker that I want here. So, like, these aren't markers here, but you also can't use them in an expression. I ended up giving up and deep copying structs because otherwise it seems impossible. Yet somehow I can get away with not deep copying a generic function. When you're saying deep copy, you mean like in your backend, or like I assume you have some generic version of the struct and you're deep copying it for the like instantiation or whatever. That's what I assume you mean, but I'm not sure. Okay, so marker is a bad name for these. What this really means is a directive that can be used in an expression is what this means. The struct has an AST associated with it, and I deep copy the AST per generic instance of the struct. Gotcha. Gotcha. So, because these can't be used, so instead of marker, we'll say preproc expression. How about that? So in the lexer, these can all still be preprocs, but okay, here, let's simple directive, we'll call this directive token pair more generically. These are simple directives. Okay. So these will be the ones that you can use in an expression. So custom simple directives, custom expression directives, and that's fine. So simple directive. So for custom directives, we use a table lookup. No, the lexer doesn't need to know about these things. I need to go back. So, but I will rename these. All the lexer cares about is that these are preprocs. So this will be custom preproc token pair is what this will be. So custom directives, custom simple. Okay, and then in the parser, we need to do a few different things here. We need a new function that is preproc expression, I guess. Returns whether a preproc node can be used inside an expression or as an expression, I guess. Return. So first, let's assert that the node's type is a token preproc, first of all. Because we shouldn't be calling this on anything that's not a preproc. And then node type, let's do this. Type is node type. Type is that. And then we will say node, how are we storing this? Preproc. Okay, so wait a minute. These are not tokens anymore. This is AST. Oh, wait a minute. Okay, hold on. Right, never mind. This is not... No. We need to see if the node is... We're not dealing with the node here. We're dealing with the token. Whether a preproc expression, preproc this is telling us whether this preproc can be used as an expression. So this is before we have a node. We're determining what kind of node to make right now. So we return with the token, short string. Is this a short string or a dynamic string? God, I don't even remember. Get token text. It's a dynamic string. Text. Get token text token. Okay. So text is equal to file name, function, line number counter, stringify. It's all of these basically. So okay, so we grab all these. And we say text equals this, or, okay. So, the token, or the preprocs that can be used in an expression are not external, oops. File name, function, line number, counter, stringify. So, let's go back to what we were doing, simple directives. So, if the next thing is a preproc token, we right, so we check, what did we call this? Custom directives. So we can just say if this is one of our custom directives, we don't recognize it, and we say if not is preproc expression, next, right? No, directive. Oh, we already grabbed the, Let's make this just be, take the dynamic string, I guess. Text, let's just do that. So, if it's not a preproc expression, then and actually, we can bounce out of this early before we even do this loop. We can start there, right? First, we see if it's even an expression, which means we don't even have to check this part, actually. Parse expression leaf. So no, we do. We're not bouncing out of this, actually. No. This is where we grab all of our preprocs, I think. This just determines what type it is, right? I have to double check now. So, oh, these are still called markers. Let's, no, it's not. Okay. these are just for expressions. So yeah, we can just check this. Forget this whole thing. We can just say, if it's not a preproc expression, then hey Chris, how's your night going? So honestly, if it's none of the, we can just say, we can move this error up here, honestly. Right? We don't recognize this preproc in the expression if it's not a preproc expression. And then this, we can change this to expression. So let's do that. This will be expression. This will be expression. Marker. This will be expression. Already did that. Okay, cool. Cool. So, instead of marker, this is now also expression. This is custom directives. Oh, Chris's message was actually like 10 minutes ago and I missed it. Oopsie. Okay. Don't need the match ID anymore. So if we see a preproc token in an expression, we make sure it's an expression token, create the node, stick it on there, we're good. Let's see what all we've broken so far. We're still using marker somewhere. Match ID we're using still. Wait, we can just use the directive here. We can just use the directive. Marker. Wait. This is in CodeGen. Yep, this is expression. Are these all? Yeah, these are update custom preproc expressions. Preproc marker has no member. Wait, really? Oh, right, marker, duh. This is now. Whoa, what did we do? Stop. Preproc expression. Okay. We're failing update function call if macro. 143. Okay, I screwed something up here because I'm not sure now if that was the right place to put this. Update function call if macro. Update function call if macro. So for each function call, this tells me that there's something about this that I'm forgetting in terms of I'm worried that this place I just edited the macro or the preprocs handled more than just those simple ones. Oh, wait, hold on. Am I... Is this now an error because it doesn't know what this is? Yes. Oops. Okay. It doesn't know what this is. Great. Okay. We're fine. So, stringify. Let's go back to the parser and preproc. Do parse. If token is preproc, include define undefined. If not defined, if else. Do I have params? Okay, I don't have a good way to just go through those. I want to reuse this. So let's take this and parse preproc params. Params. Parse call params. Let's put this up here. Node assumes the cursor is... Let's do the same thing as these other ones, which means... Well, let's do this first. Parse preproc params. It's going to take the parser, the parent node. Okay. Does it need the con? No. Okay. This is a token. All right. Parse preproc params. So let's not skip over the parent because we are telling it it's to expect that that's there. Let's pass it the def node. Oh, yes, yes. And that's it. So that should still be working as it was. Parent node, preproc param, line. It doesn't have line. Where's line coming from? Wait, why is that not on the correct line? That's weird. Can't I just use next line? That's weird. I'm not sure why that's the case. What are you currently working on? So if you look in my stream agenda below the stream, you can see what I have laid out. But the last thing that I have to do that's like feature-wise, I think, is... I think you mentioned, or you were around last time when I mentioned about snippets being like my replacement for macros. Right, because they're parsed, they're not just textual replacements. One of the things that they're missing compared to macros is stringification of things you pass to it. And I figured, actually, I can already do stringification because it's the exact same process as me spitting it out to the final code. You can just pass it a node and I can stringify it. So I'm introducing another custom directive here for stringification, and I'm pretty sure I don't have to limit it to these snippets. I'm pretty sure anywhere where you put stringify and put stuff in here, as long as the thing in here is valid at the place you call it. So like in here, argument is fine because it's going to get expanded, right? Anywhere else you put it, as long as the thing in there is valid that I can turn into a string, you can just place those anywhere. So stringification is what I'm doing right now. Hello, Brian JIDC. Welcome. Can you show the definition of short string? Yeah, short string is just a counted string. So it's literally just a shortcut for strings I know are going to be super tiny. In this case, 128. It's just a character array of 128, and then I store the length, so they don't have to be null terminated. So, I mean, they are relatively big, but I use them in places where I would be using a character array anyway. For mostly I would be using, I have another dynamic string, which again is counted, but you allocate it. So short strings are just where I'm using places where I just need, I don't want to allocate dynamic memory. So, so like I'm working on a parser right now. So all the tokens, for example, go to the lexer. Dynamic has size before it's UTF-8. A dynamic string is just one where you allocate the it's not a static array. It can be any size. So you're allocating it. Yeah, so for the upper limit on tokens, that was just as I've been getting things working. I do have just this insane number of... This is just as I've been getting it working. I can change this literally whenever I don't want to be doing this stupid thing anymore. And I actually support... So this is actually really legacy. I haven't actually come back and looked at this in a while. I'm actually glad you mentioned this. The lexers already can be set up chained, like a linked list, for example. The parser already supports chaining a bunch. Even on the same file, you can chain the lexers together. So, these are just strings of characters. As you can see, they're just bytes. Where'd it go? Right, they're just characters. Oh, I use them. I use them in place of char stars. So, anywhere where I would be using a character array for strings. So I use strings, for example, like in my parser here, all the tokens, I store the file path of the current file that's being lexed. The tokens themselves can either have a short string for their text, or if it's longer, it can be the actual text. Is there a need to store the tokens? Can you not store the current tokens? So there are two ways that I've seen people write these parsers. One is you just eat the tokens as you go, use it, and then you don't need to store it anymore. I'm storing the tokens as a giant... I'm storing the tokens in the lexer, and that's because I have multiple places in the parser where it either wants to go backwards or whatever. It wants to go backwards and forwards and stuff. I'm trying to think how hard it would be at this point to change it to just, like, on the fly ask for tokens, but yeah, so for any of the stuff where you're seeing short string, dynamic string, they're set up in such a way that I can switch them out pretty easily. So as I've been getting this thing working, just throwing in a short string for file path is totally fine right now. So I'm not thinking that too deeply about those types of decisions, because they can be swapped in and out pretty easily. So, and right now all of these paths are relative. They're not full paths. So, in fact, we're doing TODO cleanup today after I get stringification working, and that actually might be one of my to-dos, is to swap these out for something more long-term and dynamic. Okay. What were we doing now? Right. So parse preproc params is what we're doing. Gotta support full length paths on Windows. There's some weird syntax that lets you store like 32K path or something insane. Yeah, thus far I've been developing this strictly on Mac or on Linux, and I do have a very basic Mac port going. I obviously plan to support Windows. Windows is just not my daily driver, so I'm never in Windows that often. When I eventually go to do the Windows thing, I'll definitely come back to that. The maximum path is 32,000 blah characters is approximate. The prefix may be expanded to a longer string at runtime. Cool. That's fun. But yeah, so the limit on the path is just, as I've been getting this working, I'm literally the only one using this and probably will be for the foreseeable future, so the short paths literally aren't an issue, and they, like I said, they can be changed out very easily. So yes. So if we do that, I think we should still be okay. Oh, I gotta remove that again because I'm not supporting this yet. Oh wait, hold on. Okay, now I am breaking something. Parse preprox params is not doing what it's supposed to be doing. As long as the next, so okay. Oh, I'm not skipping the, I literally said this should assume that the next thing is an open paren, and I didn't adhere to that. So if it's not an open paren, we error. Otherwise, we grab the open paren. Or no, we should grab this. Grab it. If it's not an open paren, it's an error. If it is an open paren, we go right past it. So, next type. We're failing here because okay. Let's see what the next do I not have a way to just print a token? No, really? Okay. Yeah, exactly. Time for more coffee. Oh, I just got rated by CM Griffin with a party of 51. Thank you. Hello, everybody. This is more viewers than I've ever had. Hello. We're just doing some metaprogramming over here. So, hello. I just broke this and I would like to figure out why. Hi everybody. Thanks for joining. Thanks for rating. If you're curious about what we're doing over here, just working on Elixir TypeScript stuff. Cool. This is in C, and I have written a metaprogramming metaprogramming system in C that whenever you build, it compiles your metaprogram, runs it, which spits out a bunch of code, and then it compiles your main program. And you can do all sorts of fun stuff in the metaprograms, like here's a function, for example, that will generate 2 string functions for all of your structs. So this is what the metaprogram looks like. It's just C. So you can say like for each node of type, you can see here when it says running metaprogram, that's what's getting run here. You can just loop over all the structs in your program, for example, and spit out code. You can create, functions. You add them to your program, and it basically generates a giant syntax tree that it will then spit out in code. And as part of that, I am also exposing some of that to this textual layer. So for example, you can define structs and pass it types to like dynamically create them. They're like templates in C++. So like any struct, you can pass it stuff. And you can do, you can create functions, and I have this any keyword that you can make a parameter of type any, and it'll generate those functions on the fly based on when you call them. This ellipses is for variable numbers of arguments, so as long as it's your last parameter, you can have var args, and you can access them through this for any keyword. You can loop through them and do all sorts of stuff. So yeah, we're having a good time over here. I made content about macros in TypeScript and my own meta version of some macro-like functionality. Cool. If you're curious for a better, less like rushed overview of how this system works, if you look in my channel description, I actually did make a YouTube video just kind of going over the system, because a lot of people would join the stream and ask how it works. So I did make a resource you can go look at kind of offline if you feel like it. But yeah. So right now, with the way my metaprogramming system works, macros don't really fit into it because macros don't really fit into this system because they're just a textual replacement of wherever you put it. And I want to be able to parse all the code and build a tree out of it. And trying to parse the macros in C just didn't sound very fun to me. So I've created this like snippet concept, which are basically macros, but they're scoped and they're parsed like actual code. So they're parsed into a syntax tree, and then wherever you call them, it inserts that syntax tree that it parsed in the place of the snippet call. But in doing that, I'm missing certain things that macros let you do, like this stringification. So that's what we're doing tonight, is getting this new stringify keyword to work. And the way it works is, since I'm already spitting out this final code, since this is all generated code over here, I can take a node that represents something on the tree and spit it out as a string. Since I can already do that, I think I can make stringify work anywhere. Yeah, no worries. Thanks so much for rating. That's exciting. I appreciate it. You have a good night. So yeah, if anyone else is curious about this metaprogramming thing, I started streaming a month or two ago, and I'm enjoying putting that out there. So definitely going to do more of it. So if you're curious, definitely give me a follow. I like sharing this stuff. I'm very excited about what I'm doing. So have you read about program slices? I know what slices are in like Python and stuff. Is that what you're referring to? Or that's when I hear slice, that's what I think of. It's like taking like little views, like ranged based views of data. Is that what you're referring to? Okay, so how did we break this? You know what, let's just step into here. Instead of guessing, let's just step into here. People are still shooting off fireworks, so apologize for the noise if you hear any. Parse pre-prop params. Let's go here. Oh, we fail a lot. Oh, is it this again? Yes, oops. Okay, so we grab the next token, it's a parent open, good. Grab the next one, it's a preproc param called type. We create it, boom, grab the next one, it's a parent close. Assert the next one is a parent, oh, duh. After we parse them, we have to grab the next token again. Because this skipped everything, and then we have to see what the next thing is. And it should be, if we went into it with an open paren, we parse the parameters, it should put us at the closing paren. So, still didn't work. So let's see why. Parent close. Next is preproc body. Wait. Really? Why are we at the body? Oh, because we grabbed it. That's why. That's why we grabbed it. So instead of grabbing it, let's if the next one is a param, then let's just peek the next one. Actually, let's just peek in general. We shouldn't be grabbing these. Peek the next one. If it's a param, then advance to the next one. So, okay. So, if we see a parameter, we create the node for it, and then skip it and look at the next one. So now we're not skipping the closing paren if we see it. Unhandled token, parent close. Okay, so we're still getting there. Let's say you have a software and you're interested in some variable xdcat in a range, and you want to remove everything in the program, but only keep the instructions necessary to have the same inputs generate the same range for xdcat. So xdcat wouldn't even know it is only running a smaller variant of the original program. Oh, okay. I see what you're saying. I have not read about this. That almost sounds like you're... This analogy might not quite work, but it sounds like you're taking a function or a subset of functions and making that the whole program for some given scenario. That's really interesting. Yeah, I have not heard of that. Okay, so we grab... So this param node is type. We skip past the param we just saw, and now next is a parent close. So we're done. Although next here is still... Oh no, it's parent close. Okay, so we got it. Oh, then we need to skip it. We need to skip it here. So let's grab it in this case. It's been a while since I looked at this parsing code, so... Okay, we're back to compiling, we're back to running, so great. So now we can parse preproc params with a single function call, which is great. That's what we wanted to do. So in the case where we see in an expression leaf, so I don't know how you would do it. I would have to see more of the whole problem space. I just now understood what you meant by program slices, so I've not heard of that before. So it sounds interesting. It also sounds like you'd be constrained to... I feel like you'd have to write your program in such a way that any of these individual slices or functions or whatever would not depend on anything else, but... Again, this is the first time I'm hearing of this, so sounds crazy, but okay. So if it's a preproc, we create the node, which is an expression, and let's also parse. We'll say if let's see, hold on. we advance, so we say next peak token parser. If next is a token parent open, we will parse the params. Parser and preproc node. Well, it must be true that they don't depend on anything else to fit the definition. Right, exactly. Okay, so let's just make sure that still works. This is type. Nice. While you were getting coffee, I got rated by like 51 people by somebody, so that's pretty cool. Okay, so we're back to compiling. Great. So let's do this. Let's print out the tree because I need to know and actually let's print out the tree just for main. Linux main.db. Oops. Okay. I want to add a define here just to see if this worked. So define test 5. So here's our define that we just made, test. Its body has a length of 1 and its value is 5. Let's give this an argument and see what we get. Make sure that works. So it's a define called test. It does have a parameter called arg and then the body. Great. So that all works. So now, if this is a snippet called test, does that work? It's a snippet called test. It has a parameter called arg. Great. So now let's go down here and let's just do this and say stringify 5 and just see what we get. Okay, let's stop printing the tree and stuff. Unhandled token on 69. So preproc expression. So we do have this stringify. Oh, and so this is the case where we're not doing the closing. So we do this, and then we advance the token. So we skip over the closing brace in that case. Or closing paren. That still didn't work though. Next equals peak token parser. Okay, still didn't work. Let's see why. So we don't need this anymore. Let's go to parse expression leaf. Does anyone have any questions, by the way, since we have kind of a lot more people here watching, which is awesome. If anyone has any questions about what we're doing, what's going on. If you have like broader questions about the metaprogramming stuff, I have a video in my channel about page, or about stuff below the video. Kind of going over the whole system here. On my YouTube. Okay, so we are here. Let's go here. Okay, so next in this case is a parent open. Oh, no, that's right. Hold on, that's right. So we skip over the parent open inside there and we parse the parameters. So next is parent close. So that didn't actually work like we're expecting it to. The next is an open. So next is the unsigned int. Oh, it's an unsigned int, right. Oh, because this is not a preproc. This is a, this at this point is a function call. That's why. We are not even in the right place right now. So that does not happen here. Duh. That's me forgetting how this system works. We turn macro calls like this, or preproc calls, we parse them as function calls, so we let the existing function call stuff handle it, and then later in a post pass over the tree, we recognize any that are macros or snippet calls and we update them later. So we need to go to parse function call. And we need to look at that. So oh, but that's a preproc expression, so we're not going to hit that. That's why. I think. We're on line 69, so let's go back to do parse here. And let's go back to do parse and grab next and say next line is 69 and the file starts with an L. Let's just say that. Nice. I resisted saying nice. I'm glad someone in chat picked up the slack. Thank you. We're gonna say Lexer, what is it called? File something? File path? File path. Data 0 equals L. Okay. Oh, okay, we don't even hit that. Update, wait, we don't hit that? Why? Okay, interesting that we don't hit that. We're hitting CodeGen 143. Update function call if macro. Which, right, that should be what we should be updating that to a, okay, let's do this. Say Lexer, file path, data 0, L. Let's do that. Oh, wait, duh. This starts with, no wonder. Right, these are relative paths, so it's not, this is the third character. Yeah, so now we're in Linux main DB line. So we're in print. So let's go down. It should not be a function or variable decal. It's not. We parse expression. Okay, so let's see the expression we got back. We got back a function call, right? So we're parsing this line right now. We should be getting back a function call, which we did. The function call's first child is the decal ref, the function you called. So this should be print, which it is. This is print. The second child is the first parameter, and then it goes down the parameter stack from there. So the first is a string literal, which is %/n for our print. And the second parameter is another function call, which is right. We want this to show up as a function call to start. Should be a function call to stringify with one parameter. So let's look. See, so the name is a preproc expression. That's exactly what we wanted. And the literal 5 is the parameter, which is the first parameter. So over here in CodeGen, when we do update function call if macro, this function does not yet know that the declref, the expression, the name of the function, it doesn't yet know that it could be a pre-proc expression because I haven't had those yet. So this needs to accommodate that to say it's either a declref or it's a pre-proc expression, right? But this isn't even the right place because this is not a macro, but I'll do it in both places. This is actually a snippet, so same thing. Actually, no, it's not. This doesn't have to be updated because macros aren't even a thing here, so we can ignore that. So I think that's all we need. Oh wait, no, we are in function call. Hold on. Is it a macro? For each define. Oh no, okay. We need that in both places. That's fine. Because we still have to check in both places. Okay, there. So now on line 67 of the primary chunk, unable to resolve type for parameter. So we are going to take a look and see how this is failing now. Unable to resolve type for parameter. Did this update our primary chunk or is it not getting there yet? So unfortunately it's not getting there yet. So let's see. Unable to resolve type for parameter. Unable to resolve type. So this is in get param type. Which makes sense because, okay, this makes sense. So if we look at the tree, and actually let's not print it to a file, let's just grep for main again. Let's just do that same thing. Let's do 874. Oh wait, we can't see the tree because we're failing. Okay, that's fine. So what's happening here is obviously it can't determine this thing's type because we haven't defined what stringify does. So it doesn't know what type this parameter is. The node on the tree right now, it has no idea what this is, and in fact, if we print out the node here, so if we print node, or let's print the AST of the param node at this point. Actually, let's do its parent so we can see the whole thing. So here's the function call. It knows the format. This is going to be generated later, so that's fine that that's unknown. But this ellipse arg0, this should be. It's basically generating this print function. It's generating a print function that takes a string, and it takes a something. I don't know what it is. So we need to. Now we need to define what stringify does. So if we go to CodeGen, update function call if snippet, so post pass. So that's where we do this, right? Update snippet calls, replace snippet calls, and I think in replace snippet calls is where we do where do we do that part? Yeah, in update snippet calls. So update function call if snippet, we do it there. So in our post pass, we will let's see, update custom preproc expressions. Let's do that. Update custom preproc expressions. We will say if we are in a stringify. So for now, let's just assert false, make sure we hit it, first of all. which we do. Great. So if we're in a stringify, let's print out the node that we're replacing right now, which is node. So once we're done here, this preproc expression, which we're not actually printing out right now. Print let's print those out just so we can see it on the tree. You shouldn't ever need to see this on the tree, but we might as well print them out. So this is a expression. No, it goes down here. Nope, it goes down here. So the expression will be just the name. We just want the name. So we will print out node info preproc expression name. So now when we print this out, we should see that this expression here was a stringify, right? And I think we want quotes around that. Right, so this preproc expression is stringify. We want to replace this node on the tree with the stringified version of whatever its expression was. So so let's actually print out its first and only child node. So node children, well, the first node is actually the first node is actually itself, or the first child is actually the decal ref, like its name, so it's actually the second child, but print AST. So or maybe I'm wrong. I could be wrong. Nope. So why doesn't this have any children is the question. Because it should have the things you pass to it as, but it doesn't actually. All you can see here, it's just the preproc expression. So interesting. So when we do the preproc expression, right, we do the preproc expression and then move on. We need to, that thing I removed from here before, we actually need it in here. So next is peak token parser. If next is token parent open. So if we're parsing an expression and we hit a preproc, we need to see if it took parameters. So because if it's a preproc expression that takes parameters, we need to put them onto the AST. So if it's a parent open, parse function call params, I think. Parse call params. That's a bad name. These should match, but it's okay. Parse call params. So I'm actually already passing a context into here. I'm just not using it here. We should use the context here too. In parameter, because this can handle both things. So let's say it's before the open paren. So we will say in parse expression leaf, if we see an open paren, let's parse the call params. And where does that put us? That skips the closing paren. So we don't have to do anything here. We are going to parse them into the preproc node. And this is going to be a preproc expression context. Next type. I did that last time too. Okay. We didn't get any farther. This is still... So we did this part. It's adding the preproc expression. Right. This is get token. What is next? Am I peeking here? Yes, I'm peeking, so I actually have to skip this. Skip the directive. Right? So we see the directive, we create the expression node, we have to skip over it. We were doing that down here, but... Oh, wait. Sorry, this just needs to go down here. Duh. There we go. So now our preproc expression stringify, it has a parameter. Great. So that's what we wanted to do. We're parsing those like function calls now. So in here, we can say, what does append node as string do? Okay, unfortunately, oh, that's a problem. This doesn't just get me the node as a string, it appends it to a string builder. So I can do the time-consuming thing, that is also the proper thing, and have this return a string that you can use for whatever purpose. Or I can do the gross thing that'll just get it working right now and use a string builder for this, which I'm going to do that first just to get it working. And we are going to put some big old to-dos in here. Don't be lazy. Using a string builder here just to save time. Rewrite append node as string to give you the string. All right, so builder, hacky builder, how about that? What is it? Is it initialize string builder? Create string builder. Create string builder, the parsers arena, and we are just going to call this. We're going to pass it the hacky builder. We are going to pass it the child node. I guess we should assert here that you have a child. It should, but if it doesn't, there was a problem somewhere else, right? Node children 0. The file path doesn't matter. Right lines doesn't matter. And synthetic line numbers doesn't matter. I think. This is a metagen string builder. Okay. Yep. This is even grosser now. This is so stupid. Crap, okay. Don't look at this horrible code. This is not even remotely permanent. I have a to-do cleanup task next, and this is all going away. I just want to see this working. Cursor. I'm missing something. Thank you. Okay, we're compiling now, so let's print this just to make sure that we are seeing it correctly. String is build string of the builder. And let's just output the string. This is Hacky Builder. There we go. So we got the parameter as a 5. If this thing was like a file name, right? Append node as string. Ooh. Because that's still an expression at this point. We haven't... Right. Stringify should come literally at the very, very end. So update custom. This needs to come literally after everything else. So update... we'll say run stringifies. This has to happen after everything has been expanded and we know we're in a good spot. So run stringifies, it will take the parser, it will take the AST, and we do this. So we will do this. We want this whole thing. Yes. Okay. Name is this. We don't need this more than once, so let's just grab it. Great, there we go. There is that argument, file name, it gets expanded, and then we stringify it. It's already a string, so that's actually not a great example. Let's do line number. Let's print out 69 this way. There we go. Oh, and it gets casted. Okay. Okay. Let's do it before we cast things. Let's cast things at the end. There we go. 69. But remember, we're printing this out by stringifying the line number node, which is great. That's fantastic. So if this is like a function call to, let's say, print this, will I see this? Does that work? There we go. So we can print out whatever's in there just like a macro. You can stringify whatever this is. That's awesome. So now my question is, if I take this, put this in a snippet, right? If I put that in a snippet and call the snippet stringify, does this work? It does. We still work. Okay. Wait a minute. I am being dumb because we're still printing it out over here, I think. Run stringifies. We're not working. This is me printing out the... Okay. We're working in that it's getting sent down properly. We're not actually doing the thing yet. I was preemptive. That's fine. This part should be the easy part after we've already done what we did. So run stringifies. If anyone has any questions about what we're doing here, we are almost close to the final output. I can help answer what we're doing, but so instead of building the string, instead of writing the string here, we want to inject we want to replace this stringify node with a string literal node on the tree. So right now on the tree, there's one of these. There's one of these that has, as a child, it has a well, whatever you passed it, right? So in this case, if it was the line number, right? It could be like, right, 69. So this is what's in the tree right now at this line. So there's a function called a print. It's got one child, which is a string. It's got another child right now, which is one of these preproc expressions. The job of this thing we're doing right now is to turn this into this. We need to replace the node on the tree with this. That. So this node and its child all going away. It's getting replaced with a string literal of whatever you passed it. So we are going to create a new node, right? Replacement node is create node on the what does this take? It just takes the type. So create a literal string, and the string literal node takes info dot literal dot type is a what are the types here? It's a token. So token literal string, and the value dot string equals allocate d string on the parser's arena. And I think we can just pass the string. Pretty sure. And then all we have to say is replace node. Replace this node with the replacement node. Okay, well, unable to find string literal operator. Okay, some weird stuff's happening there. Let's, we are compiling though, so we're getting past running our metaprogram, and we're trying to compile the main program, which means we can go see what code this spit out. If we go to main, we can go see what this spat out. It's not the prettiest to look at in here, but I just want to see what nonsense it's spitting out. Here we go. Print. Well, there you go. It did it. That worked, right? If you look at what it did, that worked. So why is that failing? That should have actually just straight up worked. Right? So here's if I do it manually. If I do it through this, it doesn't. So let's put these side by side and go look at the tree. And let's print it out to a file this time, because I don't feel like... What's with the line thing? Okay, so I can explain that. So the way this system works, even though this is technically like my own little language here for these .db files, ultimately I'm still piggybacking off of the C compiler to do the actual work. So the final code I spit out after doing all the metaprogramming, I'm spitting out the syntax tree to a C file. That's what this C file is. So ultimately, at the end of the day, when it says compiling main program, running main program spits out this crazy thing. Compiling main program is the part that's calling out to, in this case, GCC, but it could be MSVC, whatever platform you're running on, it calls out the compiler. What it's compiling is this one single file, which is your whole program. The entire AST that I generate is being spit out in this one gigantic file. What's cool is there's a preproc directive in C already called line. This is just a C preproc. I didn't create this. You tell it a line number and a file path, and it treats the next subsequent lines of code as if it's coming from this file at this line number. So if I even had more stuff down here, like, right, like whatever, this would be line 20, this would be 21, 22. It's basically, it'll treat the subsequent lines as starting from here. What's cool about that is I'm manhandling the code gen and spitting out this crazy file. But it means both the debugger and the compiler respect this. So what's really cool is all the code I generated over here, if I want to go debug it in like VS Code, I never have to look at this craziness. I can set breakpoints over here and step through it like normal. And what's really cool is because I'm spitting out these chunk files, these are the codes that's being generated from your like function templates and stuff. I can set a breakpoint here, and it knows it knows how to hook the code up. So this is being generated from this function template, right? I have this function called test function. This takes a struct template, right? So I have to generate a bunch of different of these test functions over here, one for each type you can pass it. But all of these things, if I go look at in final, you can see all these different calls that call different things, they report the same location. So if I want to debug this for any one of these all map to this same line. So no matter what crazy dynamic generation has happened for generating all these functions, I can step through just this one for any of these call sites, because the mapping is such that these all have been mapped to the same place. Hopefully that makes sense. It's a little crazy. Definitely like you said, it's a little cursed if you were to do this in certain other scenarios, but in this case, it means debugging and compiling are none the wiser that I'm doing all this crazy stuff. And it's pretty cool. So if I have an error in this here, which is my struct template, my function template, the compiler will tell me that it's here, not in one of these crazy places over here that I generate. It's pretty wild. If that didn't exist, if that preprog didn't exist, the crazy thing I'm doing now with generating all this code would be way harder to debug and step through. So thankfully, that's just part of the C spec. I can piggyback off that. So, yeah, it's pretty crazy. So we were looking at this. Let's see what this did. Let's open it up in Emacs and see here. What did this generate? So here's the first one. It's a function call called print that takes a %in and, oh wait, no, we're down here. Function call print %/in, print will I see this. Function call print. That sure looks like it should work to me. Am I wrong? Let's comment out a lot of this stuff and simplify this. So let's do the tree, and again grep for Linux main.db. Let's look at this again. So nope. Let's do a little bit more context. Okay. So we should expect to see 2 function calls. Actually, let's make these the same. this should be like this. And let's escape these. Let's see what's wrong. So this is function call. Will I see this? Function call. Will I see this? Oh. Do those need escaped? Is that why? Will I see? Aha. We need to escape. Yes, we need to escape anything that's in there. So this works, right? I think we verified that worked. I think. No. Okay, that doesn't work either. If it's a string already, we need to escape it. So, because now if I look at this again, see this? Yeah. Oh no, if it's a string, we just need to not put... Okay, hold on. Where are we doing that at? It's in CodeGen. Run stringifies. That's why. If it's already a string, when we call append node as string, right? Append node as string is putting extra quotes around it. So what do we want to do in this case? Because file name is being expanded into a string literal, so you wouldn't do that anyway, honestly. You would never do that, right? But you might do that for like this, right? Wait. Ah, okay, I'm getting lost in the sauce here. Okay, you might do it for this, right? Which breaks us. So, although I wonder if you ever would do that. I'm trying to think what the right thing to do here is. Because you would never really do this in practice, like this, but if it's a snippet and you're like printing out a call site or something, right? So if this is, let's do this. Let's call this snippet and say file name. Oh. That also doesn't work because we expand it. Okay. This is expanded, so this is the same as me doing this. Right? This also will break in the same way. Yes. I believe. Yes. So you can see here. Okay. We need to not... So if the node is already a literal string, right? If node type, wait, no, this is the child. let's grab the child out. Child is this. So if the child's type is a string literal, we'll do one thing. Otherwise, we'll do this whole crazy nonsense. We'll do this. We'll create the replacement node. That's a string. Then we'll do this whole crazy thing, and then we'll replace it. So if it's not a string, we do this stupid thing that we'll come back to. Otherwise, we can just say this string. We don't even have to do this. We can just say is node info literal value dot string. Oops, what did I do? Child. Push size. What? Does this have to be? That might be getting eaten at some point, so we may have to copy it. Nope. Now we break. If it's a literal string, all right, let's, before we do this, let's just print out what it is we're working with here. This thing. Oh! Pay attention. This is not the node, this is the child. Child doesn't, or the node doesn't have a string yet. That's the whole thing we're doing. There we go. Okay, so we see that now. Stringify. And actually for stringify, let's do this. There we go. So we print that out now properly. If we pass a string to it, we do not add an extra set of, we don't add an extra set of quotes to it. So that's good. Can we do function? There we go. Cool. And if we do this stupid crazy thing, what happens? I'm guessing this is still going to fail spectacularly. Yeah, but would you ever do that? I don't think so. That's me hand waving because I don't feel like thinking about this. I don't think you would ever do this. It seems like a dumb thing to do. In this case, yeah. So we'll say actually think this through. Is this even a thing we have to support? Okay, great. So all this stuff is working now. Let's turn off all these comments and just turn on all the printing that we're doing in here. And just go through what everything should be. So these are all to-dos that need fixed. Okay. Just see if this still compiles. Conflicting declaration of any struct short string 64. Oh, I already have something called my string struct. Simple. Look at that. Everything prints out like it should. Everyone's happy. Let's put this side by side so we can see what we're doing here. So, starting at the top here, we create a any struct, which is just a struct that has a value determined when you instantiate it, whose type is determined. So here's one with a U32 that has this value. Here's one with a short string with hello world in it. And we're stressing out the print system as well by just %%. We pass it those things. Here we go. Here's the first struct. It's got that number in it. Here's the second struct. It's got hello world in it. Great. Next one, we create an any struct 2, which not only has a type determined for its arrays, it also has a size determined for this static array. Its size is determined when you create the struct. So here we're saying an any struct 2 that has 32 floats in it, an any struct 2 that has 64 short strings in it. We print out all this nonsense here. We're not actually doing anything with these, it looks like. We're just showing that we can instantiate them. Here we have integer storages, which are these things. They're just showing that you can make the array size when you call it. So we have one with 128, 512, 1024, small, medium, large. We have this helper macro that just gets the size of a static array, so we can show that we can grab them statically. Cool. We call my function passing it the small bucket. So this is showing, so I've instantiated 3 different ones, right? Integer storage with 3 different things. Behind the scenes, it's taking this and generating, you can see here, it's generating, it just post fixes like the any parameters to it. So here's the 128 version, the 512 version, the 1024 version. Those got generated from these calls. Where are we? So what this does, here's a function that just takes integer storage, right? It just takes this, right? This function takes one of these templated structs. It should be able to be called with any of them that gets generated. So here, I'm calling test function, or I'm calling, where's my function? I'm calling my function with a pointer to the small bucket. But remember, the small bucket is one of these, right? It could also be one of these or one of these, depending on how you did it. This function should support all of them, and it just works. We're calling my function. It should print out the bucket size for the one you passed in. We passed in the 128, and it just works. So we can pass it any that we instantiate off of this, and it just works. Next, we create a bunch of any struct 2s, one with 1 U32 in it, one with 2 short strings in it, one with 4 U32s in it, and one with 8 of them. And we call test function on all of these different crazy ones. So if you look here, not final, we're looking at primary chunk. So here's all of those, right? Any struct 2 with 32 floats, 64 short strings, 1 U32, 2 short strings, 4 U32s, and 8 U32s. We just call that 4 times on our 4 different things. And again, this just takes the any struct 2. And it should generate, here you go. It generated a version of that function for every single one of these, right? And we print out all of their values, which are, here's the 1 int, here's the 2 strings, here's the 4 ints, here's the 8 ints. That's all of these here. Cool. Everything's working. Damn, it got late. I don't know if I really feel like... that ended up being a little bit of a rabbit hole because there was some stuff I had to fix to make that work. But now that it is working, the next thing I want to do is start tackling all of the... We have a bunch of to-do debt that has built up in this thing. So if I just search for to-do, we have a lot of to-do debt that has built up. And I've been wanting to do features and not hit these to-dos. So some of them I might do off stream here and there when I feel like it, but definitely the next stream I do, we will be hitting a bunch of these to-dos. And we're almost at the point now where I feel good enough about all these features that I just need to test a little bit of the robustness of them, but I'm kind of ready to move on to actually doing stuff with this whole system, which is going to be starting out writing my platform layer for Linux, and actually start doing stuff. I'm excited. Yeah, if you're curious about watching all that stuff happen and watching me continue to build upon this, definitely give me a follow. It's cool that I got rated, and a lot of you guys looks like you've stuck around and stayed watching, so that's cool. I really appreciate it. Yeah, if you're curious about how this whole system works kind of at a higher level, definitely scroll down below this video and look at the What is Metaprogramming video that I made. It kind of goes over my whole system. It's missing some of the features I've added, but it gives you a really good idea about top to bottom when I run this, the compiling and running the metaprogram, compiling your main program, like that whole process. It goes over that whole thing. So if you plan on watching me and you're confused about that, that should be a good primer to how it all is working. And yeah, definitely appreciate it. I'll probably be streaming tomorrow as well. I've got a long weekend this weekend, so I've been doing more streaming, and I will do more in the future. So yeah, thanks for hanging out, everybody. Thanks again to CM Griffin for giving me the raid. That was very, very cool. Very nice of them. That's the most viewers I've ever had on this, so that's awesome. And yeah, I will catch you guys later. Definitely give me a follow, and I've said that like 20 times now. I'm not used to doing the call to action thing. I'm new to this whole thing. So thanks for watching. Thank you. That's very nice of you, in YouTube chat. John Damono says, I'm awesome. Thank you. I appreciate it. Cool. All right. Have a good night, everybody. Hi, Ty Guy. I'm just now signing off. I appreciate the follow. Yeah, if you're looking for more, definitely going to be doing more streaming. So thanks a lot, everybody. I will catch you all later.